So what do we think? Which one do I know I can throw out? D. We talked about piecewise functions yesterday. When I'm looking at this piecewise function, here's the name of the function, g of x. And I know by looking after the curly bracket how many pieces I should be expecting to see, because each piece will be represented as a line of information. How many pieces am I expecting to see? How many lines do I have after the curly brackets? 3. There's one right here, one right here, one right here. So I'm going to expect to see 3 different or distinct graphs all sharing space. Okay? So 3 different graphs sharing space. Each line of information is not only telling me what the graph looks like, but it tells me where it lives. Or you might call it its address. So here's one of my functions, here's a function, and here's a function. These are my rules. They tell me my slope and my y-intercept. One of those looks weird compared to the other two. Second one, that 3 right there, that's called a constant. Whenever you have a value that's a constant like that, it's just a straight flat line like this, at however high or low that number is. So this one is going to be up at 3, straight flat line. After the word if, this information back here, this gives me the location or the address, where this piece lives. Have you guys ever heard the phrase, good fences make good neighbors? Has anybody ever heard that before? So the meaning behind that, I don't remember, I think I heard my grandparents say that years ago, but the idea is that it's a lot easier to get along with your neighbors if they stay in their yard and you stay in your yard. You don't go messing around with their stuff and they don't invite themselves over and start messing around with your things. A good fence, a good boundary line between you and your neighbor means that you guys get along better. So these locations, these addresses, these are going to tell me where the fences go. And each of these functions has to stay in their own yard. If they cross over into their neighbor's yard, they're not being a good neighbor. So I'm going to look through all of this inequality stuff, and I'm looking for numbers. Yes, ma'am. Absolutely. Make sure you have your ID and pass. When you look through all those inequalities, what numbers do you see in there? Yeah, I see a -2 and a +2. This tells me that I'm going to have fences at -2 and +2. My fences are always going straight up and down like this. I'm going to draw it on graph D for just a second. Because we talked about, right at the beginning when I started going over this, we know we can throw this one out. This is not correct. And I want to look at why. There are 3 different lines here. Are they staying in their own yard or are they crossing into their neighbor's yards? Well, these red lines are the fences. Here's one of the graphs. Did he stay in just 1 yard? No, he's stretched out across all 3 yards, right? What about this guy? Did he stay in just one of those yards? No. When I'm looking at piecewise functions, these guys have to stay in their own yards. They're not allowed to cross over that fence and get into somebody else's space. So that's how I know we can throw this one out. They crossed fences. All right. I'm going to use that as we look at these other three graphs to narrow it down from here. I'm going to draw those same fences in here, +2 and -2, and I got those numbers again from the inequalities. When you look at this one, is he in just 1 yard or did he cross a fence? Just 1 yard. He's just over here, right? He doesn't cross that line. What about this guy? Is he staying in his yard? And this guy? Okay. So I'm looking for those pieces. I can draw that on each of these other graphs to check to make sure that people are staying in their own space. Are they being good neighbors, staying in their own yards here? Yep. He stays in his yard. He stays in his yard. He stays in his yard. What about in graph C? Are people staying in their own space, in their own yards? Yes. So now I'm looking for anything else that is different between these three graphs. What differences do you notice between these three? Open and closed circles. Let's look first at this one. Which fence am I on here? I'm on the first fence, the -2 fence, right? And if I'm looking at this dot on each of these, this line is going which way, left or right? It's going to the left. These two both have -2. Which one tells me it's living on the left side? Is it the top? Yeah. This one right here, x is less than, left of -2. X stands for like what part of the x-axis, where is his yard? I want the part of the x-axis that is left of -2. So I'm looking at this guy right here as I look at this dot. Look at this inequality. Does this have an or equal to with it? No. What's the difference between the way I graph an or equal to versus just a greater than or less than? Do I shade this one in or not? No. This guy right here is going to be an open dot at -2. Which ones of my graphs have an open dot there? B and C means I can definitely throw out graph A. This right here should be open. All right. So now I have to narrow it down between these two. What's the only difference between those two? Yeah. On this one right here, I have an open dot right there. On this one up here, I don't even see a dot. If you don't see, if they didn't put like a big filled in dot like they did here, it is a closed dot. They're just coming together. If you don't see it, there's a closed dot there. Question. What would it look like if I looked at one of these inequalities and it had just a less than, so I know I do an open dot there, but then I look at another inequality and it has a less than or equal to there, and so I know I'm supposed to do a closed dot there. What does it look like if I put a closed dot on top of an open dot? It's going to look closed, right? It's going to look all filled in. What would it look like if I put an open dot on top of an open dot? Open. I would have one dot that's open, and I would have another dot that's open right on top of it. So I'm still going to see this open dot here. So which fence am I looking at? 2, +2. So I'm going to come over here and look at the +2s. Excuse me. So I'm looking right here, and I'm looking right here. The only way I get an open dot like this is if both of them should be open. Are both of these supposed to be open? No. This one says it's supposed to be closed. So which graph shows me That they're not both open. Yeah. B up here is the correct one. This one shows me that they're not both open. That's the correct one. Graph B is correct. Domain and range. Domain for this graph. If I'm talking about domain, am I paying attention to the x's or the y's? X's. Which way does the x-axis go? Right and left. So I'm scanning back and forth, right and left. All right? I can even use my vertical line to help me do this to keep track of it. If I have my vertical line over here, is there somewhere in this yard that my vertical line is crossing the graph at? Are there any gaps over here, or is there a graph here? There's a graph right there, right? When I go into the next yard, is there a gap here where there's nothing on there, or is there part of a line there? There's part of a line. It's up here, but I'm looking anywhere in this space here, back and forth. There's a line here. There's a closed dot here and an open dot here. I need one of these to be closed, and only one, and I've got that. I come over here into this yard. Is there graph over here, or is there a gap? There's graph there. When I'm checking this domain, especially if I have those fences in there, I'm just making sure that there's not an empty lot anywhere. Does that make sense? I want to see that there's a graph or a function living in each of the lots side by side. None of them should be empty. If I see that they all have a graph living in that space, then my domain is all real numbers. If there's a gap, I would have to say where that gap is. It's all real numbers except this gap space. So my domain is all real numbers. For my range, am I still visually scanning things from left to right? No, I'm going which way for the range? Up and down. Now I'm looking this way. And I'm checking to see, are there any places where a graph does not exist in that space? Somewhere. If I'm right here, and I'm going all the way across, I can cross fences as I'm checking this way. Is there any graph that lives in this space? Yeah, right here. In this space, across any of the yards, is there a graph that lives in this space? Yep, over here. I have this guy who's just a flat line. What about up above this? No. There's nothing that lives up above this. So there's a gap up above, and everything below it has a graph somewhere in that space. So all of my y values are less than or equal to, they all live below what? 3. They're all living below 3. All right. We're going to be in your books. Page 48. We're looking at example number 2, page 48 in your book. We're going to keep talking about piecewise here. The reason we bring up piecewise so early in the year in Algebra 2, there's a lot of real-world situations where we see piecewise functions in action. Have you guys ever been to the store and seen a sign that they're like, if you buy 5 or more, we'll give you a discount? Like it's like $2 off if you buy 5 or more. Have you ever seen something like that where they give you money off if you buy a large quantity? That is an example of a piecewise function in the real world. I want to read through this one right here because here's another example for us. Football coach is ordering new jerseys for the season. If you just need a couple of them, you need 5 or less, they're $88 a piece. Kind of expensive, huh? If you need between 6 and 11, they give you a discount. If you need between 6 and 11 jerseys, you only pay $75 a piece. Still pretty expensive, but it's some money off, right? If you need between 12 and 29 jerseys, you're going to pay $65 a piece. And if you need to outfit your whole team, as long as there's more than 30 players on the team, it's only $56 a piece if you're going to get 30 or more jerseys. Hopefully these are really well made and they can last for a couple of years, right? So those are pretty expensive. Very expensive. But if you get to use it for 4 years, or the school, like if they charge a rental fee for it and they turn it back in at the end of the season, that could work. I mean, if it lasts a long time, it might be worth the money. I don't know. I don't know how well made these are. Over here, we're going to fill this in. What's the name of this function? What is the function notation before the curly bracket? What did they name it? F. This is my function f of x. What do you think the x means? What would be changing each time as different coaches are putting in these orders? The amount of jerseys. So x right here is the number of jerseys ordered. That's what it means when I see it here in the function notation. That's what it means when I see it here in these different rules. The number of jerseys ordered. Why are they multiplying the number of jerseys by 88 here? What would that tell us? Tells us the cost for what? The amount of jerseys. If we buy how many? Yeah. This is $88 for each jersey. And so if I multiply those together, it's going to tell me my total cost to buy that many jerseys, right? Depending on what I put in for X. When are we paying $88 per jersey? Is it, even if I want 200 of them, it's still 88 bucks a piece? When do I pay $88 for each jersey? When we're buying 5 or less jerseys. So I want to try to find which of these inequalities, which of these restrictions tells me that we're buying 5 or less jerseys. What are we looking at here? What do you think? Top row or bottom row? Top row. Which ones stand out to you from the top row? 5 or less. I'm kind of keying in on both of these, right? Like they both seem to say less than 5. How do I decide between those? The one that says what? I'm sorry, I still can't hear you, and it's my hearing problem. So. The one that has 0 in it. I like that. Is it possible for me to order 4 jerseys? 3? 2? 1? Is it possible that I go on the website and I decide I'm going to hire or I'm going to buy these from somebody else, and so I buy no jerseys? Is it possible to purchase -1 jerseys? No. That's how I make the decision here. In this particular context, because we're talking about actually ordering things, I can't get a number of jerseys that's smaller than 0. That doesn't make any sense. So I'm going to go with this one. 0 is less than the number of jerseys that I'm ordering, is less than or equal to 5. What does 75x mean? Like in the context of this problem, what's it representing? $75 each. $75 for each jersey. When are we paying $75 for each jersey? 5 or fewer, it's 75?
5 for each.
6 to 11.
6 to 11 jerseys. is when it costs me $75 each. Which inequality would let me say that? Yes, sir. Yes, you may. I want between 6 and 11 jerseys. Which inequality would let me choose between 6 and 11 jerseys? Last one in the first row, this guy right here. That looks almost identical to this one, right? Why wouldn't I go with this one? What's different about these two? Says less than or equal to, right? So this one says if I have exactly 5 jerseys, it would meet this. But I already know how much I'm going to pay if we get exactly 5 jerseys. How much are we going to have to pay for each one if we get 5? I got to pay $88 for each. Welcome, welcome. So we're going to go with this guy right here. Oh, not 0. I need a number that is bigger than 5. 6 is bigger than 5, right? Has to be bigger than 5, but less than or equal to 11. You can sit in any open spot, and you have 25 minutes. Okay. What about 65x? What does that mean in context? Explain that to me in the story. What does 65x mean? Yes. We're going to pay $65 per jersey if we get between 12 and, I'm sorry, I just didn't hear the last number. 12 and 29. Which one of these inequalities lets me choose between 12 and 29 jerseys? First one in the bottom row. Bigger than 11. 12 is bigger than 11. All the way up to 29. So far, so good? All right. We've got one more to go here. When would we pay $56 per jersey? When we're buying 30 or more jerseys. Which of the inequalities that's left says I'm going to get 30 or more? X is greater than 29. This one right here says I'm going to get more than 29 jerseys, because X is how many jerseys we're getting. What does this one say? Yeah, 29 is bigger than the number of jerseys I'm getting, which means less than 29. And that's not what we wanted to say. All right, we're looking at this. I want to go and find out what the shopping cart total is going to say for some different order amounts. All right? We want to get 11 jerseys. What's the shopping cart total going to be if we're getting 11 jerseys? How do I figure this out? You got to keep your head up for me, dear. We pay $75 per jersey. So if I need 11, we're going to do 75x, but then I'm going to put the 11 in the place of the x. So 75 times 11. Does anybody need a calculator so that they can do that? Anybody else need a calculator? If you're not grabbing one from me, I expect you're doing it on your phone then. I want everybody to pop this one in their calculator. Okay. How much is it going to cost to order exactly 11 jerseys before tax and all that jazz? $8.25. What about if I wanted to get 25 jerseys? Is it 75 times 25? 75 times, or is it 75 at all?
It's 65.
65. We get a discount for getting more jerseys. So 65x, where x is the number of jerseys here. So 65 times 25.
You get 1,625 dollars.
1625, absolutely correct. This last one looks weird. They didn't give me a number of jerseys on the last part. What did they tell me? It says F29. Where did the F come from? Yeah, that's the name of our function right here. And what did we say the X represents here? Number of jerseys. So even though they wrote it differently, what are they asking me to find here? Cost for 29 jerseys. Find the cost for 29 jerseys. How do I find the cost for 29 jerseys? 65, because we're still paying $65 per jersey. And we're going to put 29 in the place of the X there. How much would that be? I heard 1,800 and then I didn't hear the last two numbers. 85. 1,800. This is not cheap, is it? This is why I'm hoping they can reuse them year to year, because that's getting really expensive. All right. I'm going to put a problem similar to the bell work up on the board. And we're going to try to pick out which one of these goes with the situation that's being described. All right, so this is catering. What's a caterer?
Somebody who serves food.
Yeah, they make and serve food, right? And they normally charge per head or per person. How many mouths am I feeding? This caterer charges $150 to set up a party. That's just, they're like, I got to get supplies, I got to hire people. It's $150 if you're going to book a party with me. And then it is $6 per person for the first 50 people. If you're going to have a big event and you're going to have more than 50 people there, for every person over 50, you only have to pay $4.50 per person. So what are all the things that somebody would have to think about if they're going to hire this caterer? All the things that they might need to pay. How much do you have to pay up front just to book a party? $150. Does that change for anybody, or is that the same for everybody? Same. Here's your setup fee. So no matter what the total is, like, it has to include this $150. You're not getting out the door for less than that. What else do we have to think about as we're planning this party? Yeah, $6 a person for the first 50 people. If you had a party with exactly 50 people attending, how much would this part of it cost? How would I find that part out? Yep. $6 per person means I have 6x for 50 people. Now I've got 6 times 50. And Michael, you said that was how much? I think you're right. Does that mean if I want to have a party with 50 people there, it's going to cost me $300? How much does it cost then? $450. Why $450? We have to have that setup fee. I'm actually jumping over here to part B. We'll go do part A in a minute, but I kind of want to think through this first so that we can make it make sense. All right, so we have our $150 setup fee. We're going to add the $300. This is $6 per person times 50 people for a grand total of $450. What about if I wanted to have 85 people at this party? You said 85 times 450?
No.
Why not?
It would be 35 times
35 times 450. Explain to me what you're thinking. I like it. You're right. Explain it so the rest of us can understand why we're doing 35 times 450.
because the first 50, you got times that by 6.
Yes. The first 50 people are going to cost us $300 plus the setup fee. We pay $450 per person for each person over 50. So person 51 through 85. So when I come down here, 85 people, I'm going to subtract out the first 50. We have 35 people left where we pay $450 each. Do I still need to pay the setup? Do I still need to pay the setup fee? Yeah. Do I still need to pay this $300? For the first 50 people, I do. So I'm still going to have this 150. I'm still going to have this 300. And then we're going to have more cost. How do I find how much more it is for these extra 35 people? 450 times what? 450 times 35. What is 450 times 35? You said 157.5. So 50 cents. Since we're talking about money, are you guys okay if I put the 0 on the end of it? Money, we always go to 2 decimal places. So if I ever just see 1 in my problem and it's a money problem, I'll add a 0 on the end. What do I get if I add all those up? How much is it going to cost me for this party? How much is it going to cost me for this party? $607.50, right? All right, let's come over here and try to pick out which of these piecewise functions is describing this. Remember, I've got to pay this $150 no matter what. Do all of these options here include that setup fee? I see one right off the bat that does not include it. Which one do you see? A. So I'm going to throw that one out. It doesn't have my setup fee there. All right. Looking down through these, what in the world is up with this 450? That's not the setup, is it? What is that 450? I feel like we've seen that before already. Yeah, this is the setup plus the 50 people. Because this is if we've got more than 50 people coming, right? So 450, that makes sense. Why is this one 150 then? That's the setup fee. Do we still have to pay for the first 50 people? Yeah. Is this right here including paying for those 50 people? No. This one I can throw out too. Because that bottom inequality, or that bottom equation, that bottom rule, I'm not paying for the first 50 people. But I really do have to pay for the first 50 people. So this is not right. This is not going to give me an accurate amount that I would have to pay for this party. So now I'm narrowing it down between these two. What's the only difference between these two choices? Yeah, this one has P minus 50. This one has P. What does P represent? People at the party. Do I only pay $4.50 a person if I have more than 50 people coming? No. I pay $4.50 a person for everybody that comes after the first 50. So I take 50 away like we did right there, and then I know how many people I'm paying $4.50 for. So option C is the correct answer here. This one is saying it is only $4.50 for every person. Give me a real quick check-in with where we are. I want to know first for part B, when we found those numbers, tell me how you're feeling about that. Finding how much we're going to have to pay for the party. Jaden, head up for me, dear. Where are we at with finding how much we're going to have to pay for the party? Ibrahim, eyes up here, please. Narrowing down which rule would work for the situation. Give me a quick check-in. Where are we at there? Okay, cool. Piecewise functions are not easy. If you're sitting here or here right now, that's pretty normal when you first start learning piecewise functions. If you're still confused about them, I'm not freaking out and worried right now. We're going to continue to work about it and talk about it, okay? One more kind of piecewise function that I want to talk about today, it's called a step function. It looks kind of like this graph right here. Based on what the graph looks like, why do you think we call it a step function? Kind of looks like stair steps, right? Stairs that aren't evenly spaced, but there's still these stairs hanging out on my graph. Have you guys ever been in or driven past a parking garage before? They have the big signs out front so you know how much you have to pay if you're going to park in that parking garage, right? Do they charge just one price at most parking garages? Some of them do.
It depends where you park it.
Depends where you park at, absolutely. If I go down and I park in the mall parking garage for Circle Center Mall downtown, I know this one because I just parked there not that long ago. There's a big sign out front, and they're like, if you're just running in for a quick trip, you're going to be here between 0 and 30 minutes. It's pretty cheap. It's like $5 to park if you're going to be there for a half an hour or less. If you're going to be there for more than a half an hour, they have that broken down into different price points. From more than 30 minutes up to like 2 hours, I think you pay like $15, something like that. If I parked my car in that garage, and I'm planning on running in and running out real quick, I'm like, I'm gonna be here 30 minutes or less, I got the $5 for this parking. And it takes me a little bit longer to check out than I thought it was going to, and I end up getting back to my car at 35 minutes. How much do I pay to get out of the garage? Yeah, I pay that like 10 or 15, right? There's no in-between prices. You either pay this price, if you don't get out of the garage in time, then it jumps up to the next price. They don't care if it's only a minute or two later. You make these big jumps. That's what I'm seeing happen on this graph. You're right here. When you run out of time, all of a sudden it jumps up to the next one. There's no in-between price. They're not going to charge me $5.50 or $6.75. It's these whole dollar amounts. And they don't care if it's only 5 minutes into that next time. These are functions, because if I take my vertical line and I run it over the graph, is that crossing my blue graph in more than one spot? What about here? What about here? No. The only places where I could maybe do that at is like right here. Do you see how I've got 2 dots there? But one of them's open and one of them's closed. That means if I fall right at this number, it actually already jumps me up to the next one. That open dot is an okay thing. Does anybody remember what continuity means? If it's continuous. What does it mean for it to be continuous? Never stops, keeps going. I can put my pencil down on the left side of this graph. I can trace along this graph, and I don't have to pick my pencil up and off the page until I run off the graph on the other side. That's continuous. Can I do that with this graph? Can I draw the whole thing without ever picking up my pencil once? No. I can do this part without picking up my pencil, but that's not the whole graph. I got to jump up to the next tier. As soon as I have to pick my pencil up, we say it is no longer continuous. Step functions are not continuous. We're on page 149. Or sorry, not 149, just 49. Sometimes, instead of writing not continuous, they'll say discontinuous. Domain. Left and right or up and down for domain? Left and right. Is there an arrow pointing to the left? No. Where's the spot farthest to the left where we have a dot? -4. On the left, my graph starts at -4, right here. As I move across that graph, here, 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 can I keep going past that? Nope. So what's the farthest to the right I can go? +4. In between +4 and -4, there is a point that has an x value everywhere in between there. Right down here, I have all these different x values from -4, -3, -2. When I get to -1, it actually jumps up here, but then it keeps going. When I get to here, it jumps up here, but then it keeps going until I get here, and then it doesn't keep going anymore. My range. Now I'm looking up and down. If I were to name the different ordered pairs in here, what are all the possible y values I would see in those ordered pairs? -3. All of these down here would have a y value of -3, right? What's another y value that we can get? -1. Anything else? Any other output values, y values? +3. And nothing in between them. There's these gaps. It is only at -3, -1, and +3. My step functions are always going to have ranges that look like this, where it's just a list of how high or low those steps are. Let's look at one together. We're going to look at example number 3 in your book. This is real data from the post office. In 2016, they adopted these rate changes. How much does it charge to send just a small letter, according to this? If I just want to send a small, tiny packet, it's not very heavy at all. Weighs less than a paperclip. 47 cents. Does anybody off the top of their head know about how much a paperclip weighs? It's about 1 gram, which is metric units, and these are English units, but paperclips are really, really light. 47 cents for a letter that is not over 1 ounce. Could it go all the way up to 1 ounce? If it says it's not over 1 ounce, can I go all the way up to 1 ounce? Yes. 47 cents. Look at this table over here. If X is my package weight, would anybody send a package that weighs 0 ounces? No. That's literally nothing. So it has to be bigger than nothing, less than or equal to 1, and I pay how much for it? 47 cents. Let's go and graph that here. Where is 47 cents on this graph? What are they even counting by? 0.4 for everywhere it shows me a number. What are those little lines in between then? 0.2. So this is like 20 cents, 40 cents, 60 cents, 80 cents. Here's $1, $1.20, $1.40, $1.60. It goes all the way up to $1.80 up here. 47 cents is really close to what? It's really close to 50 cents. I'm probably going to have to ballpark or estimate 50 cents on this graph. Where would 50 cents be? In between 40 and 60. Do I want an open dot or a closed dot at 0? Open or closed? Let's go look at our inequality. What's my inequality at 0? It's going to be an open dot. Another way to think about this is, do I actually have to pay 47 cents for a package that doesn't exist? No. Then I'm going to have an open dot. I pay 47 cents for this package if it is 0 ounces all the way up until what? 1. So anywhere between 0 and 1 ounce, I pay 47 cents. What about if my package weighs between 1 and 2 ounces? How much do I pay for it now? 68 cents. 68 cents, as long as my package is not over 2 ounces. Where does that go on my table? Where does that go in my table? Which one of these says that it's not over 2 ounces? Second one down right here, 68 cents. How do I put that on my graph? 68 cents is really close to what? 70 cents. So open dot here, because if it's exactly 1 ounce, if I somehow manage to nail it right at 1 ounce, I pay 47 cents. 1.01, and I jump up to the higher price. And it stays flat at 68 cents until we get to what? Until we get to 2 ounces right here. What about if it's more than 2 ounces? How much do I pay now? 89 cents. It can be more than 2, but not more than how many to only pay 89 cents? Yeah, not over 3 ounces. So I would pay 89 cents here. So in between 2 ounces and 3 ounces, it's this flat rate of almost 90 cents. What about if it's more than 3 ounces? $1.10. Is that for any package over 3 ounces? I only get up to how much? $3.54. That costs me $1.10. So does that mean that this next step looks like this? Does that represent this correctly. What's wrong with it? This one goes all the way over to 4, but it should stop where? 3.54. It should go just a little tiny bit past the halfway point. Domain and range real quick, and then we'll stop here for today. Where's this start on the left? Is there an arrow? What's the farthest left this graph goes? 0. Open dot or closed dot at 0? Open. So I'm going to have a parenthesis and then a 0. I can keep following along. Might need to take an elevator up until I get to what? What's the farthest to the right I can go? 3.54. Bracket because I have a filled in dot this time. And then we've got range. When I have these steps hanging out, my range is those numbers where the steps are. What's the lowest down one? What's the cheapest I could pay? 47 cents. So 0.47. What's the next one up? 0.68. And then what? 0.89. And last? 1.10. Those are all the possible prices that I could pay. According to this, would I ever go into the post office with a single package and pay exactly $1? Not possible. What about 50 cents? No. These are the only 4 prices I could possibly get. All right. We're stopping there for today. You guys have homework that is due on Monday. There's still one piece that we need to talk about tomorrow. Another kind of piecewise function that we'll talk about. Here is what your homework assignment is. You'll be turning it in on Clever. Here's those problems in your book. Problem number 1, though, you would need to change one of the numbers to make it match the online homework. All right? Yes, you may. Let me know if you guys have any questions or need any help with anything. I'm happy to help you during this study time with your math stuff if you have questions.